Welcome, students. I am absolutely thrilled you're here today. We are going to dive right into this explainer and learn how to build, run, and simplify massive algebraic machines step by step. If you've ever stared at a long, super intimidating math problem and just wondered where to even begin, you are in exactly the right place. I'll be your friendly virtual teacher today. Let's get our digital notebook all set up so we can learn algebra completely from scratch. I want you to treat this just like you're sitting in a real classroom. So grab some paper, grab a pencil, and get ready to take some notes. We're going to break everything down so clearly that by the end of this lesson, you'll be solving complex problems like it's totally second nature. Now, to get started, think of math like a giant, highly logical machine. Just like a physical machine needs tiny screws and larger gears to actually function, our algebraic machine uses tiny numbers and letters to build larger, really functional mathematical structures. It's all about balance and how the pieces fit together. Here is our game plan for today's explainer. We're covering numerical versus algebraic expressions, equations, inequalities, and formulas. Then we'll identify like terms, learn how to add and subtract them, simplify complex expressions, and finally, we'll wrap up with a math practice challenge. Stick around because I'm going to show you a quick trick or two that makes identifying these parts incredibly easy. All right, part 1, numerical versus algebraic expressions. Let's look at the basic parts. So to understand our machine, we first got to figure out its smallest individual components. Take a look at the numerical expression here. 3 times -6 plus 4. It's called numerical because, well, it consists entirely of numbers and basic arithmetic operations. There are no mystery letters. But right next to it, we have an algebraic expression, -5k. The very second we mix in a variable, a letter representing an unknown value, like our k here, the whole expression becomes algebraic. Fun fact for you, the word algebra actually comes from an ancient Arabic word, meaning the reunion of broken parts, which is exactly what we're doing with our machine today. Moving right along to part 2, equations, inequalities, and formulas. This is where we build the structure. Let's see how these basic expressions actually connect to form larger structures. It is really all about the concept of balance. An equation connects two mathematical expressions with an equal sign. That literally means one side weighs exactly the same as the other side. 3x plus 1 is perfectly balanced with 5. An inequality, on the other hand, uses a sign like less than or greater than. For instance, 2x is strictly less than x plus 1. This means our machine is intentionally tilted. One side is just heavier. And then we have mathematical formulas. Formulas are basically just equations, but they represent factual real-world rules or principles. Think about finding the area of a square. Step 1, we identify the rule, which is multiplying a side by itself. Step 2, we simply write the formula out as A equals S times S. Okay, time for a quick knowledge check. I want you to literally pause this explainer, open up your notebook, and try to translate this exact sentence into math before I show you the solution. The total number of boys, X, and girls, Y, in a classroom equals 35. Also jot down whether you think it's an equation or an inequality. Go ahead and try it right now. All right, let's work through the steps together. Step 1, we add the boys and girls, so that gives us X plus Y. Step 2, the phrase literally says equals 35, so we write down our equal sign and a 35. Put that together for step 3, and we get our result. X plus Y equals 35. And because we have that equal sign balancing both sides perfectly, we have successfully built an equation. Give yourself a pat on the back if you got that right. Part 3, identifying like algebraic terms. Time to sort those machine parts. Now that we've got our expressions and equations, we need to organize our machine by grouping similar parts together. In math, we call these like terms. The absolute crucial point here is that like terms are algebraic terms that have the exact same variables raised to the exact same powers. Honestly, it doesn't matter at all if the numeric coefficients, the numbers sitting in front of the letters, are totally different. The letters and their exponents must be a perfect match. Think of them like identical shapes in a sorting game. Let's look at this example straight from the lesson material. We have -5k, 1/5 k squared, 3k, and 7k squared. Take just a second and see if you can mentally group the matching variables. Which of these pieces actually belong together? Let's see a quick trick for this. Just circle the matches. First, we group the terms with a single, plain k together. That means matching up -5k and 3k in one group. Next, we look for the k-squared variables. We pair 1/5 k squared and 7k squared together. Why did we keep them separate? Because a k is entirely different from a k squared. You can only combine absolute exact matches. Part 4. Adding and subtracting terms. Let's get this machine running. Excellent sorting. Now that we've organized our parts, let's learn how to combine them using addition and subtraction. But please, be careful here. Seriously, this is a massive exam trap. Verbal expressions like subtract A from B actually translate mathematically to B minus A. Many students make a mistake in this step on tests because they write it exactly in the order they read it, left to right. But remember, if you take A from B, B has to be your starting point. Time for another knowledge check. Grab that pencil again, pause the explainer, and carefully write this out using the trap rule we just talked about. Write the expression for subtracting 5x from negative 3x, and then go ahead and calculate the result. Don't fall for the trap. Let's see how you did. Because we are subtracting 5x from negative 3x, we have to start our line with negative 3x. Then we write minus 5x. For step 2, we use the distributive property. By pulling out that common variable x, we're basically just doing simple arithmetic on the coefficients, negative 3 minus 5. That gives us our final result, negative 8x. Part 5, Simplifying Complex Algebraic Expressions, the Masterclass. Take a deep breath because we are ready for the masterclass. We are going to put all these rules together to simplify a massive algebraic equation. This is a very common exam question, and yeah, it looks pretty intimidating, doesn't it? 4 times the quantity negative 2a plus 3b minus 2 times the quantity 8b minus 3 plus a. But don't panic. We just need to break it down one simple mechanical step at a time. Let's write out the solutions step by step. First, we distribute to blast open those parentheses. 4 times negative 2a gives us negative 8a. 4 times 3b is 12b. Now the next part. Negative 2 times 8b is negative 16b, and negative 2 times negative 3 is a positive 6. And hey, don't forget to drop down that plus a sitting at the very end. Step 2, we group our like terms. We put our a terms together, negative 8a plus a. We put our b terms together, 12b minus 16b, and our lone constant, positive 6, just stays by itself. Finally, we simplify. Negative 8a plus 1a is negative 7a. 12b minus 16b is negative 4b, and plus 6. Our final form is beautifully simplified down to negative 7a minus 4b plus 6. And finally, part 6, the final math practice challenge. Let's test your skills. Fantastic work so far. To wrap up this explainer, let's put your brand new algebraic superpowers to the test with a rapid-fire geometry challenge. Say we need to find the perimeter of a triangle with side lengths 4y, 5y, and 6y. Perimeter just means adding up all the outside edges. So we write p equals 4y plus 5y plus 6y. Since they all have exactly the same variable y, they are like terms. We just add up the numbers. 4 plus 5 plus 6 equals 15. So our simplified expression is 15y. Now, what if the problem asks us to evaluate the perimeter at y equals 2? We just substitute that 2 in for the y. 15 times 2 brilliantly gives us a total perimeter of 30. I'm leaving you with one final puzzle to tackle on your own. Find the perimeter of a polygon with side lengths 4x, x, 2x, 3x, 2x, and 4x. First, write the expression and simplify it by combining your like terms. Then, evaluate the total perimeter when x equals 4. Try writing this out in your notebook right now. Keep practicing these steps until you completely master this algebraic machine. And, once you've conquered these flat two-dimensional perimeters, ask yourself, what happens when we take these algebraic machines into the third dimension? How exactly would you build a formula for the volume of an algebraic cube? Ponder that, keep practicing, and I will see you next time.